Hi, everyone. Welcome. My name is Eileen Huster. I'm part of the marketing team at Zappi Group. With us this morning, we have Thorén from Scania, who will be speaking about the electrification of heavy vehicles, the charging challenge. I just want to remind you that the session is also being recorded and will be available to watch on demand afterwards. If you have any questions during the session, please add them to the Q&A, and that is a button that you can find on the top right of your screen. The questions will be sent privately, and we will do our best to answer all of them. And with that, I welcome Christer, and please take it away. Thank you for joining us.
Thank you, Eileen, for the introduction. And I will just share my screen and go from there. Just a second. Okay, so I will talk about heavy vehicles and how it's possible to electrify them and why.
Christer, sorry, I believe you're
Yep.
sharing a different screen. So just
Okay, then I will.
It's showing the actual panel.
Okay, I will try to redo it. Sorry about that. Got a strange message. Okay, let's do it again. Yeah, here we go.
Perfect.
Good. So to start with, who am I? I did my thesis many years ago working with HVDC. I have a background in power electronics at Chalmers University in Sweden, and so I did my thesis about HVDC and what is now called HVDC Light, which is very interesting. But that is done in a small town in Sweden, and I wanted to work or actually live in a bigger town. So I joined, which is now called Bombardier, but at that time was ABB Traction, working with power supplies for trains. And this shows the Danish trains that we electrified, and I worked with that for some time. After that, I moved to Ericsson and designed power supplies for telecommunication equipment for a couple of years. But for the last 20 years, I've been working at Scania, and for the last 10 years with electrification of heavy vehicles. So this is me. Okay, some a little background, and you heard about this, but it's important just to remind why we are talking about electrification. All these CO2 emissions, good for the climate. And if you look to the right, you can see that many different sectors actually have been reduced the CO2 footprint, but the transport sector has not. So soon we have the largest emissions and we have the biggest challenge ahead of us. And looking to the lower right, you can also see that even though the amount of vehicles, light vehicles, are quite large, to the right you can see that the 40 ton and above vehicles, even though they are few, have the most emissions. So we need to focus on the heavy vehicles if we want to reduce or eliminate the CO2 on the road. But this is not only for the climate, but for the last months we have also realized that it's not good to be dependent on certain fossil fuel suppliers. And also the third thing is that actually they are quite quiet, these vehicles. So they, especially in cities, will reduce noise. But I would say the CO2 challenge is the biggest one. So how do we do this? Well, of course, again, electrification. The future is electric. There's no question about that. But how do you electrify? To start with, just to get some big picture, these are the components that are needed. Electric motor, of course, to drive the rear axle, a converter for that electric motor to control the motor, battery for the power, and then a charger. And so these are the main components in all different vehicles. The charger could be onboard charger, offboard charger, many different ways to give energy to the battery, but all these components are needed. Now, if we look at different vehicles, If you look at the region distribution, they are usually 10 to 20 ton heavy. They don't drive that much a day, 100, 200 kilometers. And you can do that with a reasonable battery size. That's possible to have on board. So you can charge and drive for the complete day. And if you charge overnight, you can do it with a reasonable amount of power. If you need it, you can stop at lunch and top up with the 300 kilowatt. You can charge with less than 100 kilowatts overnight, which is not that much for a heavy vehicle. So that's quite easy to electrify, and that is done now in a very quick pace, I would say. However, the long haulage, that's more difficult. Talk about 40 to 60 ton and sometimes even more. You could drive 500, maybe 1,000 kilometers per day, and actually sometimes more than that. They could use an overnight charging at 100 kilowatts to fully charge the battery. But then you need to drive for 4.5 hours, which is the regulation. After that, at least in Europe, you need to rest for 45 minutes. And then during that time, you charge the truck, but then you need about 800 kilowatt to do fully charge. And then you can drive another 4.5 hours. So these are really the requirements. You need a battery that can actually do 4.5 hour drive, and you need to charge it in 45 minutes. That is quite a big battery and a big load on the charging equipment. And the peak power is high. And also remember that these charging stations should always be one free charger. So you need to build up a huge network of chargers to be able to have all operation electric. Because a truck driver cannot wait for 45 minutes for the charger to be free. If you're a private person, okay, it's not good, but you can live with that. But these are commercial companies who need to deliver in time. So that means that you need a lot of chargers. And I took a picture of a German parking lot. This is about 100 trucks standing there. And most of them are probably standing there because they need to take the 45-minute break. And if they all were electric, they would need about 800 kilowatt each. So we're talking about 80,000 megawatts. That's a lot at one parking spot. 40 megawatt at each side. That's a lot of power that should be brought there. It's possible to do, but it's not easy. So what's the alternative then? Well, hydrogen. Yeah, you can drive long range with the hydrogen with reasonable size tanks. It's quite quick to refill. You can do it much quicker than 45 minutes and then drive another 4.5 hours. The efficiency, though, is really terrible. You need 3 times. If you want to go with green hydrogen, to actually make hydrogen out of electricity, you will lose so much during that operation. First make the hydrogen and then use it in a fuel cell. So you need 3 times as much electricity to start with compared to a BEV vehicle. And yeah, so the business case is really terrible compared to BEV. However, it's quite similar cost compared to a combustion engine. So, and also the losses in the fuel cell means that you need to cool it. It's quite similar to the combustion engine vehicle, actually, the cooling system, which makes it not really quiet. You need a lot of fans there to cool it off. But having said all this, the interest in the society is very, very good. There's a lot of initiatives in Europe to make this happen. So even though it's the efficiency is not great, we will have hydrogen vehicles. But there are actually other ways to do it. What if we could find a solution that needs less batteries, can still do the long range, you need lower demand of peak power at charging, you don't need to stop and charge so often, but still have the same efficiency as a BEV. And that is actually a train. Train takes power while it drives. This train can actually go without batteries. The efficiency is good. but the train is a train. That train is not a truck. So how can we transfer the train technology to a truck? That is the question. So what you need to do that is that you need some way of a pickup, somewhere to connect to the wire, or however you transmit the power. You need a DC-DC converter in the vehicle that converts this to the vehicle system, and then you need some safety and control system and payment systems. So there are some different technologies that has been tried in Europe. This is made by a company called Elways. They have put down a slot in the ground. It's a little difficult to explain without the old picture, but it's a slot in the ground, and the pickup goes down there and finds a plus or minus supply down there. It's not possible to reach it from the top, but it goes down in these slots and connects to the power supply. And this has been tested in Sweden for a few years. They were actually finished a couple of years ago. So they have that experience. Another technology tried is by Alstom in France, where they have, this is actually technology used by trams in France, and they transferred it to the trucks. They have two, a plus or minus on top of the road, where a sliding pickup is picking up the electricity and then transfer it to the vehicle. And this has also been tested by Volvo, who has integrated this solution in their truck. Another solution is called El on Road, where you put it, in this case, it's called El on Road because it's on top of the road. And here it's not a plus or minus. Actually, the plus and minus are, instead of beside each other, they are alternative in the driving direction. So the pickup is actually several pickups after each other being connected to one of these different segments, which is quite good thinking. It's quite narrow, and still you can get all the power to vehicle that you want. And this is tried at the moment in the southern part of Sweden. Another way to do it is actually inductive, which I know is very popular and looked into a lot in the US, maybe also Canada. But this Electron is a company from Israel who are doing tests in Israel, but also in Sweden, where they have built about 1.5 to 2 kilometer road and tested both a bus and a truck driving there inductively. So there you don't have the problem with that you need to contact or put something on the road, but this is actually hidden below the road. And you used to say it's like an electric toothbrush. It's just charged inductively. But with Scania, we actually tried a different solution. And that's using more a train-like system where you have a overhead catenary. 2 wires up there. The train only have one because they can return the current in the wheels to the track. We cannot do that with our rubber wheels, so we need to return the power on a different wire. So we have plus and minus above the vehicle. There's a pantograph that's quite similar to train pantograph, but it's actually 2 pantographs in one. And again, there's a DC-DC converter, converts this to the vehicle electric system. And then we have safety and control system and payment systems. So if you look at the technology, the grid supply today in the test that we are doing is actually 600 volt, but we will raise it to 1200 volt, which means the current is half, and we can have much more vehicles on the same stretch with the same wire, because there's a voltage drop in the wire. And then you have some fuses and over voltage protection in the pantograph, the main contactor in the tower, and then the DC-DC. And this DC-DC we think should be around between 200 to 300 kilowatts. And then it feeds directly into the vehicle system, which is usually between 600 and 800 volts. And why we say 200 to 300 kilowatt is that just to keep a truck moving in a steady state, and in Europe it usually drives between 80 and 90 kilometers per hour, you need a little more than 100 kilowatt, maybe 120 kilowatts. Do that. And with a 200 kilowatt DC-DC, you have 80 kilowatts remaining to charge the battery, which means when you are done driving on this electric road, the battery is usually fully charged. And if you go up to 300 kilowatt, you can actually charge it even faster. So it's built on Thorén technology. We have been cooperating with Siemens for 10 years now. So they developed the pantograph. They also developed the wires, because the 2 wires above the road, of course, is not something you just buy, because it's different to the train, but they have developed the 2-wire system. We put all that equipment behind the cab. If you put it on top of the cab movement will be difficult to handle by the pantograph. So put it just behind, directly on the vehicle chassis. And the black part below the pantograph, it's actually what we call the tower, where we place the DC-DC converter and some other control systems. So the one major difference between some of you maybe know that there are trolley buses, quite similar. The trolley buses also have 2 wires above the road. You connect there and then you use it for propulsion of bus. But they usually cannot connect at full speed, which we can do. We can drive at 90 kilometers per hour and connect the pantograph. Take the power there for propulsion. And when you want to overtake another truck or car, you just take down the pantograph, go on battery, pass the car, go back in the lane with the wires above, raise the pantograph and continue electric. So you're not stuck behind in a slow vehicle. You can overtake when you want to. This is today's semi-automatic. It can be fully automatic in the future if we want to. And again, you both drive forward and charge the batteries while doing this. And the platform for this vehicle can be both a hybrid truck or a purely electric truck. As long as you have electric driveline, you can connect this pantograph. We actually see it as a charging interface that can be used while driving. It's not a specific truck, it's just an add-on to a truck. So we have been trying this for quite some time now. In Germany, they have built 3 sites. They're each about 5 kilometers in both directions, so it's 10 kilometers per site. The third one is a little shorter, so in total they have 25 kilometers operating. They will add another 7 this year. And with Scania, we have 15 trucks in operation on these sites, and they are all commercial operation. Even though they're test vehicles, they're used in commercial operation 24/7, doing normal job. So they drive in hybrid mode, and then when they come to this road, they just raise the pantograph and go electric. And when they leave the road, they have a usually fully charged battery, and then they can continue electric or hybrid mode until the final destination. And we've been driving this since 2019. So it's 3 years. Soon it will be 3 years that we've been operating. And actually got order on another 7 trucks this year. So we will develop an upgraded version of the truck that you've seen there and deliver that during this year. And so far we have accumulated 1 million kilometers doing this. So we think we have a lot of experience doing this. And we think it's a very good way forward. And just to show that we are not alone there from Scania, this is a Isuzu truck that's being converted to pure battery drive with a pantograph. And we're not involved in this, but this is public information that just to show that more than Scania are doing this. And there will actually be more trucks coming out later on this year too. So in summary, the economy is good. We'll come back to that. But just before that, it's a dynamic charging interface. which means that instead of having hotspots where you need to, well, as I said, maybe you have 50 or 80 megawatts at one place, these are spread out both in time and geographically. You can think while a truck is driving, the trucks are on the road quite well spread out on the big highways. So you only need to supply the power where they are. You need to put small charging stations along the road. And also you don't need to supply all the power in just 45 minutes. These are continuously supplied, all the trucks. So it's quite much more simple to supply the energy, even though the energy is the same as before, the peak power is not. And also these trucks, as they can they don't need batteries when they are on the highway. They can use this catenary system. You need much less batteries on the truck. So they're lighter, cheaper. They can take more load. And actually on the road, these batteries we can complement with fuel cell. There's no contradiction between the fuel cell and the ERS truck if needed, if you see the opportunity. And this is just a picture taken from a German institute that compare different TCO calculations. And they all more or less show that the catenary solution is equal or better than the battery electric, and always better than the fuel cell. And of course, always better than the synthetic fuel, because if you have a 30% efficiency of the fuel cell, the synthetic fuel is more like 10%. You lose even more going over synthetic fuel. So the economy is good. And so why don't we build this all over Europe now and the world? Well, maybe we will do that. Germany, who are driving this technology, they have built all these 3 roads, but they also allocated actually 4,100 million euro, which is a lot of money, for next phase of infrastructure. And this is not only for the highways, but also for static chargers and hydrogen stations. But let's say that 1,000 million euros could be used for electric roads in the next phase. That's a lot of money. That can give you a lot of road. So the money is there, and the ambition is to have 3 pilot sites operating 2024 or maybe 25. And on the map there down there, you can actually see where these places are planned to be. It's in the southeast of Germany, which is called Bavaria or Bayern, where Munich is the main town or city. There's in the middle of Germany, close to Frankfurt, where they also want to have a stretch. And then there's the north of Germany going east-west. In the north, they're only thinking about static charger, but in the 2 other places, they also want to build more e-highways. So the money's there, the will is also there. As soon as this was made public, this picture, the German Minister of Transport said that we would like to have overhead trucks driving in our Bundesland as soon as possible. So there's money, there's will, there's technology, but of course the decision is not made yet where to build and how to build and so on. So we're just waiting for that. It's also important to say that, well, 2 things. As I've said, Germany has selected the overhead catenary technology. So if there's a electric road in Germany, it will be with wires above the road. They're very clear about that. And also this is an open standard. There are no licenses needed to operate this. And it's actually standard work is ongoing to make it even more clear how it should be. The main parts are already there, but there are preliminary standards out there, but they will probably be finalized hopefully during next year. It's fully clear how it should operate. So this is interesting. So it's happening in Germany, but we're still waiting for the final decision from the government that they will actually start to do this. But we quite confident that that will happen within a year, that the decision is made. They will go forward. They're also interested in other markets. Sweden will also have a longer electric road. They're talking about 20 kilometers. So German are talking much more. They're probably 100, 200, 300 kilometers. But in Sweden, we'll build another 20 kilometers. And the decision will be made in the end of this year. And there actually the question is open of which technology we are going to use here in Sweden. In the UK, it's a big investigation ongoing about an ERS pilot. And they have the ambition to have it operating in 2025. And with the knowledge from the pilot, of course, if it goes well, they would like to extend it all over UK. So they understand that this is existing and it's a good technology. In France, they're also very keen on ERS technology, but they have still not made a clear decision about which technology to use. They're still quite they really would like to use inductive technology there, even though it has some limitations. So we will see what happens there. And we had some also interest from the Netherlands, Belgium, Austria, Italy, Norway, to mention a few. It's a huge interest from I would say all over the world. And just an aside, I don't have any picture on that, but before the German built their roads, there were actually also a test road in Sweden, 2 kilometers, and that was in operation between 2016 and 19. And during that time, about 2,500 visitors came to that, just have a look at it, from all over the world, many, many countries. So the interest is huge about this, and people follow it, and I'm quite sure that it also will happen, because it's so many benefits doing this. And that concludes my presentation. So in summary, the future is electric. Thank you very much.
Thank you, Christer. We do have a few questions added to the Q&A, and anybody else who has questions, it's on the top right hand of your screen. There's a little sign for Q&A. We have a question from Jonah. He's asking, does the TCO shared include infrastructure? Who owns the infrastructure, and what is the cost of added power converter?
Everything is included, the infrastructure, all components needed. If you start with a clean road without anything, the TCO includes the wires, the poles, the transformers, and the added part of the vehicle. And who owns it in Germany is quite clear that the state will own this installation. In the UK, for me, it's quite clear that the state will not own it. And then France, I'm not sure. So it's different to different countries. But there's some other question also in there.
Yes, we have a question from Jiri. Where do you see the future of long-range hauling? Isn't higher usage of trains for this purpose better way to go? Or somehow hybrid combination of truck and train hauling? Trains are way more energy efficient, way less rolling resistance, needs less space, highways are much wider, and are much easier to automate, autonomous, faster.
Yeah, I would say train is a perfect solution. As I said, I worked with trains earlier in my career. However, at least in Europe, the train tracks are full. You can't add many more trains. So even though you would like, even if you wanted to do that, it would be impossible to move all the trucks to train operation. So it's a much quicker way to just build these roads instead of building new rail tracks, I would say. So they are not in opposition to each other, they complement each other. And the other thing is that if you want to have a quick delivery, it's very difficult to beat the truck. This road that we see here was built in less than a year. So it's quite quick to have this in operation. Does that answer the complete question?
Feel free to add another follow-up question if that did not answer all your question. We have a couple more. How big is the onboard battery, and how far can you go in battery operation?
I would say that's depending on the customer need. If they want to go far away from this road, they add a bigger battery. If you just have a short drive, you have a smaller one. But I would say the minimum size from my point of view would be about 200 kilowatt hours, which would give you a range of maybe 100, 150 kilometers. But that's really at Scania, we have this modular system, so it's you can choose different sizes. And also with this pantograph, you can also choose different sizes depending on what you need to do.
Sorry, and another question about the capacity of the currently installed batteries.
The contents. What you see here, they have, if I remember right now, about 30 kilowatt hours. Because these are based on the hybrid trucks that we have in production. Well, as we only developed the charging interface, the pantograph, we have to take what we have in production, and this is what we had. So they can't go that far outside the electric road, maybe 10, 20 kilometers on battery. But this is not what we will offer in a commercial situation.
Great. Marco asks, will the hydrogen production cost reduction in the future make the fuel cell solution much more competitive?
Well, you always have the problem that you lose 70% of the electricity or the energy when you go over hydrogen, starting with electricity. So that's you can't beat that. That's sort of physics. So if it's cheaper, well, it's a long discussion about the hydrogen cost and price. But I would say if you have electricity, green electricity, it's always the best efficiency is use it directly and not go over hydrogen. And the hydrogen cost in the future, that's a $1 million question, what will happen? I know there's so many different opinions, so I don't want to add another opinion to that.
Johnny has a question. Do you have an idea how many trucks can be charged simultaneously while driving on the Autobahn? Will the system have limitations due to heavy traffic?
Well, the target is to be able to supply one truck every 100 meters, which is roughly the distance you should have if you drive at 80 or 90 kilometers per hour. If there are too high demand from the trucks, actually the voltage will drop because it's a lot of current in the wires, and then when voltage drops, each truck should limit its power intake. So if you do it right, this will be a self-regulating system, where if you have a lot of trucks, they will reduce their input power, so will remain stable. But that needs to be developed further on, I would say, to make it perfect.
Carl asks, which average efficiency of the dynamic inductive charging can we expect?
Well, the efficiency of this system that we see here is the only losses we have is actually in the DC-DC converter. And I know that you can make DC-DCs with an efficiency of 98%, but maybe they will become too expensive. So at least 96% is reasonable without huge expenses. And that is the only losses you have. Then of course, you have the rectifier in the other end. But depending on where you start, the equipment in the truck is very efficient.
We have a question from Mirko. Is there in place a kind of consortium on this solution across different OEMs?
Not yet. We would like to have more OEMs on board. I showed the Isuzu, so that's one step forward. But they're only beginning. But we think that few more will join us quite soon. It's nothing official yet.
Great. And Max asks, does the charging system regulate the voltage and the current, or is this done on board on the truck?
That's on board. And let's see if I can go back to that picture here we go. If you look at this picture, the DC-DC is actually what controls the current to the truck. So the truck, if the battery is full, of course the truck only wants to have current for the drive inverter, and then it demands current from the DC-DC just for that. If the battery is empty, it will demand more current, so it actually goes also to the battery. The control is done in the vehicle using the DC-DC.
Another question that's a little bit broad, but is, let me see. What are the biggest hurdles to electrifying long-haul trucks that you see?
Well, to electrify in general, I would say is the infrastructure. Well, that's actually the answer in all cases. If you go for static charging, you need to have a lot of static chargers quite close to each other to be able to catch all the vehicles. You can catch a few vehicles with just a few stations, but if you want to catch all, they all have different places where they need to stop and charge. So you need to have a quite, would say, fine mesh system doing that. The same thing actually for the e-highways. Of course, you need to have quite a big investment up front. You probably need about 100, 200 kilometers of e-highway before it's actually commercially profitable to buy such a truck and drive it there. But as soon as you have that, it will be more or less self-going. Then you can add kilometers by kilometer with a profit, I would say. But it's always a problem with the infrastructure before you have a lot of trucks using that. It will not be profitable. And that goes for both static chargers and these dynamic charging vehicles. So again, infrastructure, that's the hurdle that we need to come over.
Thank you. And we have one last question. What was the drive for Scania to start developing this technology?
Well, we're saying that we're driving the shift, and we promised our target at least is to sell half of the trucks should be electric by 2030. That's a statement we made a year ago. Because we see that we need to go to electrification because of the climate, the CO2 problem. And so we want to be in forefront doing that. And I also see that it's quite obvious that these electric trucks will also be profitable for the customer quite soon, because they're much lower cost of electricity compared to diesel. So it's two things. We want to do something good for the environment, but we also want to be a profitable company and drive it. And why we choose also to go into this ERS technology is more that we saw the promises with this. It's also a lot of problems with the static charges. And we also saw that we had a platform to build this on top of with the, I would say, limited resources. Yeah, but so the main statement is that the future is electric, and we want to be there, and we need to be there.
Great. Well, thank you very much for your time, Christer, and thank you everyone for joining us. And remember, if any of your colleagues were not able to watch this live, the recorded session will be available on this platform soon after this session ends. And we will see you on the next session. Thank you, everyone.